Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for SAT. We have been solving SAT math problems out of this book here, the official SAT study guide. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 835. Please turn to it, page 835. And today is our lesson number 109. Listen, before we actually get into the problems for today, there was a word that cropped up in yesterday's lecture, and I told you I was going to tell you at the end. We're going to cover that word at the end, and I forgot all about it. The word was inordinate. What does it mean? I'm looking in my list of words here to see if we have actually covered it in our vocabulary lessons. So if you give me a second, I'll tell you whether or not we have covered it. Inordinate was the word. Oh, it doesn't look like we ever covered it in our vocabulary lessons. That means unreasonable. What I said yesterday was, if you can do a problem accurately, but if it takes inordinate amount of time, if it takes excessive amount of time, if it takes unreasonable amount of time, that is no good. On the other hand, you can do it fast, but you get it wrong, that also does not count. So you have to find a fine balance between the accuracy and speed. You have to have both, obviously. Question number 15 is what we are about to do here. Question number 15 is classified as a hard question. I do not know why, because the concept that they're testing here is this. If we have two quantities, x plus y, if you have two numbers, and if you take their sum, and if you multiply those two numbers by their difference, what we get is x times x, which is x squared, x times negative y, because it's a negative here, x times negative y is negative xy, then y times x is going to be positive xy, and finally positive y times the negative y is going to give us negative y squared. Negative y squared. Let's not squeeze it in there. It's getting too crowded. Negative y squared. And of course, negative yx, xy and positive xy are going to cancel out. And what we find is that x times y times x minus y times x plus y equals x squared minus y squared. All the kids know it. It is called the difference of two squares. This formula is called difference of two squares, because this is a squared quantity, this is a squared quantity, and we're looking at their difference of two squared. Here in this problem we are told that x minus y squared equals 10. We are told that. And we are also told that x plus y equals 5. The question simply is, what's the value of x minus y? Well, if x plus y equals 5 and x squared minus y squared equals 10, then x minus y must be, if you divide both sides by 5, this 5 drops out, and x minus y must be 10 over 5 or 2. That's it, we're done. The answer is 2. That's it. Number 16. Number 16. But you have to be able to recognize that this is what you have to do here. That's all. That's all they're trying to see here. There are three formulas that you must know for the exam. There are three of them. You already saw one of them, which is difference of 2 squared, x squared minus y squared. You must also know what is x plus y whole squared, and you must also know what is x minus y whole squared. These three formulas you must know for the exam by heart. That is the only reason why this question is classified as a hard question. Number 16. We are told that the distance at the top here is 1. this distance from here to here we are told is 2, and of course this distance we are told is 3. If this entire distance is 3, if this side is 3 and this side we are told top is 1 and bottom is 2, that is also 3. So it's a square. We are given a square here, and within a square we are given a shaded region that looks something like this. So this is one here, so it goes like this. This is one here, it goes like this. This is one here, right here, so it goes like this. Voila. And this is the shaded region. And the question is, what's the area of the shaded region? Well, that's very simple. The area of the shaded region is simply, equals to the area of the large square, minus the areas of the 4 triangles. If you can find out the area of each of these triangles, there are 4 of them, 1, 2, 3, 4. If you can find out the areas of these 4 triangles, you can subtract the areas of these 4 triangles from the area of the large square, we are home free. And the area of the large square is very straightforward. Area of the large square is 9. I shouldn't have put that bloody thing here, because now I have to continue here. The area of the large square is simply 3 times 3, or 9. Let's find out the area of the triangles. Let's find out the area of one triangle. Let's pick this triangle here. I'm going to give this triangle a name, so that we can, and they are all similar. They are all identical triangles. If you look at the picture, they are all the same. They all have a base of 1 and a height of 2. A base is 1 and a height is 2. You see, if you look at this particular triangle on the top, it has a height. Right here is the height, which is 2, and here is the base from here to here, which is 1. And how do you find the area of a triangle? It is 1/2 base times height. 1/2 base, which is 1, times height, which is 2. And this 2 is going to cancel out with that 2, and it turns out that the area of this particular triangle is 1. Area of one of these triangles equals 1. And there are 4 of them. So the area of the large square minus the area of the 4 triangles, and we just found out the area of each of these triangles is just 1. So it's 3 times 3 minus 4 times 1, because there are 4 of them. 3 times 3 minus 4 times 1. 3 times 3 is the area of the square, which is 9, minus a 4. Hence the area of the shaded region is 5. That's all. The answer is 5. I will see you tomorrow, okay? Bye now.